Now, perhaps you are plenty skilled at troubleshooting VLANs and even private VLANs in a traditional, like non-converged data center environment on traditional iOS type equipment. The great news, you're going to be able to leverage much of what you have learned for troubleshooting VLANs and private VLANs in the most sophisticated of Nexus data center environments, and I'm going to prove it to you right now in this nugget. Oftentimes, when we're troubleshooting at layer 2 in our Nexus environment, we want to do things like verify layer 2 connectivity between the devices in our same layer 2 domain. We want to determine and verify the layer 2 path between these devices. We want to track frames and device MAC addresses along this path. And we want to investigate links where the path might be broken. These commands that we're going to utilize to engage in this, again, stem from our early iOS environments. Your exploration might start with, is your interface actually up and sending, receiving traffic? And what type of traffic is it actually sending and receiving? So I might go to one of my interfaces like Ethernet 1/13 and say show interface Ethernet 1/13 counters. And I can clearly see for this particular interface the number of multicast packets that are in, the unicast packets that are outbound, the broadcast packets that are outbound, for example. Now, of course, we would be remiss if we didn't cover show CDP neighbors. One of those just absolutely critical commands that's going to enable you to see, as long as the Cisco Discovery Protocol is permitted in your environment, of course, it's going to allow you to see the particular devices to which you connect and the interface to which you are indeed connected. Now, are we learning a particular MAC address? Once again, a command that you've probably been familiar with for a very, very long time. It's show MAC address table. We're going to see both those addresses that have been statically placed on the particular device, as well as those addresses that have been dynamically learned. Obviously, notice the particular switch ID that we're learning them from is also a critical piece of information in this output. Now, of course, another command that's going to be absolutely critical is for us to go ahead and ensure that spanning tree protocol forwarding states are in place. Obviously, we won't be learning MAC addresses on a particular spanning tree protocol port that is in the blocking state, for example. Now, show spanning tree VLAN exists in our Nexus environment. Here, by the way, you can see we are running rapid spanning tree protocol, great for us. And notice that we have a default priority. Don't be confused on this priority. The 32768, which is the default priority, I'm sure you know, is being added to the VLAN ID, also known as the system extension ID in this particular output. Notice once again that we have our bridge ID information down in this section and the root bridge ID information up in this section. Notice also in this particular environment we are dealing with virtual port channeling. We'll be discussing virtual port channeling in great depth in this course, as you might guess, with obviously a slant towards troubleshooting it. And of course, when we look at such output, our eyes are driven to the particular role of the interface. And notice here, role and status for that matter, notice here we've got a root port, a designated port, a root port, and of course the states for those will all be in the forwarding state. So this is key output that we want to look at from a layer 2 perspective. Now, some other great tools that we're going to have our tool belt here when it comes to show commands, and okay, one of them isn't a show command, but close enough, is show port channel summary. You're probably very familiar with this command. I did not even bother to list the output here. This is going to show your interfaces that are bundled in a port channel. And most particularly, it's going to show status information that you can look up in a legend for each one of them. For instance, you might see an uppercase P to indicate that that particular interface is up in the bundle. Then there's show IP ARP for a specific VLAN. So this would be allowing us to check the proper operation of the address resolution protocol on a particular VLAN. One you might not be familiar with, and I think you're really going to enjoy this, is MAC address table notification threshold limit 45 and then a particular interval. You are specifying, look, I want to know when my MAC address table, when those number of MAC addresses hits about that 45% full threshold, and this is the interval on which I want you throwing the particular message. That way, you can control being overwhelmed by the message itself, by that notification itself. So this is obviously a critical command from a security perspective in many environments. There's something else you can do with this command, by the way. You could say MAC address table notification, and then instead of all this stuff, you could simply say MAC hyphen move. So the full command would be MAC address table notification MAC move. And now you are getting a notification message if the MAC address is moved on the particular device. So another great command that we can utilize, again, when we are doing our in-depth troubleshooting of layer 2 structures, particularly VLANs. Now, when it comes to your VLANs themselves, we know there is, of course, VLAN 1, the default VLAN that you can't even delete off one of your Nexus devices. Then we've got VLANs 2 through 1005. We refer to these as our normal VLANs. Normal VLANs, of course, that we can create, use, modify, delete. Then 1006 up to 4094. These are our extended VLANs, often called extended range VLANs. Now, your various Cisco devices, hardware devices, and software versions that are on those hardware devices are going to need VLANs for internal purposes. I no longer in a nugget will quote what those particular internal use VLANs are. Gets me into too much trouble because someone will be on a different device from the device that I'm working with, and they will go ahead and say, you quoted the wrong number. What I will do is give you this very underdocumented command of show VLAN internal usage, for instance. Hopefully you can use this command and you'll see just which of the VLANs that the internal system is using and what it is using them for. You can clearly see in my example here, VLANs 3968 through 4031 are indeed being used internally for multicast operations. By the way, some of the Nexus devices will literally allow you to go in and change. That's right. Go in and change the reserved internal use only VLANs. So that is obviously a pretty cool feature. Now remember, one of the things that we love about most of our Nexus devices is the fact that we can so easily virtualize them. We're talking, of course, about a virtual device context. And remember, your VLANs are independent in those virtual device contexts. In fact, this is a way in which we can easily go above our 4094 as far as our number of VLAN number. We could have 3 virtual device contexts, each supporting that number of VLANs. This can be very, very problematic for engineers as they're getting used to it. Here we have an engineer create VLAN 20 in the default context, then switch into a context called red and create VLAN 20. And of course, these VLAN 20s are completely distinct from each other. So let's really pay attention, as our prompt will indicate, exactly what virtual device context we are in and what specific VLAN we are working with. And of course, there's very many variations of our show VLAN command, like just getting all information for all VLANs on the switch, which we tend not to do as often as other variations because we just kind of get overwhelmed, and it gives us a lot of information that we really don't need. So show VLAN brief is a hugely popular one. Show VLAN name and then name one, and show VLAN summary are all great ways to look at the VLAN infrastructure that's actually been created in a particular virtual device context. Now, what if you had thousands of customers out there and you wanted to number all of these customers in the same exact IP subnet, but you wanted to control these customers' ability to communicate with each other? Well, sure enough, you would utilize what we call the private VLAN system. We would have our primary VLAN. Let's say it's VLAN 200. And then what you can do is you can create sub-VLANs inside of this VLAN. Let's say this is VLAN 100 and this is VLAN 101 and this is VLAN 102. As you know, for your sub-VLANs, there's different types. There's an isolated sub-VLAN, and there is a community sub-VLAN structure that you can create. So let's say we make the 100 VLAN a community sub-VLAN and the 102 a community sub-VLAN. Everybody within this particular sub-VLAN can communicate with each other. Everyone in 102 can communicate with each other. But notice 100 cannot communicate with 102 and vice versa. We go ahead and we make 101 an isolated VLAN. The individuals in this isolated VLAN cannot communicate with other individuals, but you may wonder, how could all of these entities communicate with the rest of the world? And that is, of course, with a particular port that we designate the promiscuous port. So the promiscuous port does allow all of these devices to communicate beyond this private VLAN structure. So this particular private VLAN feature, again, is a really granular way to control communications, and I want to emphasize that every single device that we are speaking of in this structure can all be utilizing the same IP subnet. We have a variety of things to think about with private VLANs in the Nexus environment. Specifically, enabling the feature. So if you are struggling to configure private VLANs in your Nexus environment, it might be that you forgot to enable the feature. Once you've got it enabled and you start creating your private VLAN infrastructure, remember there's a couple of absolutely key commands that you're going to want to remember. Show VLAN private -VLAN would be one of those particular commands. It's going to show your community VLANs, what they're numbered, what ports are participating in those community VLANs. It's going to show your isolated VLANs and what ports are in those isolated VLANs. And you could even use show VLAN private VLAN and then add the type keyword in order to display the status of those particular private VLAN structures that you have created. So, private VLANs, something to consider as well as a feature you might be taking advantage of in your data center. Now, might there be limitations on the private VLAN functionality on the particular Cisco device that you're working with? Of course there might be. So we're going to go to the documentation for that. I'll go support all products. We'll go to switches. And then we'll say data center switches. Let's say I'm on a 7000 series 7718 slot switch, and we're interested in the configuration guides. From the configuration guides, we're obviously talking about the layer 2 switching configuration guide, and here is a chapter that I would highly recommend you download and print out, because you're going to find many limitations in here regarding the creation of your private VLANs on this device. Things like particular F modules and the number of private VLAN structures that you can create and all that kind of good stuff is going to be found in this particular document. So please keep that in mind, that for these different features that we discussed through the course, something might not be working because of a particular model's limitation. Now, the great news is, for those of you interested in certification, the certification exam is going to be pretty darn good about not asking nitpicky details about particular platforms regarding a particular feature. Thank goodness, because think of how difficult it would be for you and I to memorize all the different kind of nuanced limitations of features across the different devices. Now, by the way, we're talking about VLANs and troubleshooting them in this particular nugget. You might ask, what about VTP? Well, it just so happens, look at this, right above our configuring private VLANs, we have a chapter on configuring VTP. If you're not familiar with VTP, I'm sure you are, but should it have been a long time since you even thought about it, go ahead and take a look at this chapter just for completion's sake. In most data center environments, Cisco is going to frown upon VTP. By that I mean you'd be in a VTP transparent mode and you would be manually creating your VLANs across all of your devices. Many devices in the data center do not even support VTP. So you wouldn't even have the option of using the VLAN trunking protocol to begin with. Well, it's time for one of our special features in this particular nugget. It is a pop quiz. What solution should you consider if you have thousands of systems and you want to conserve on VLAN IDs and IP subnet usage? Once again, if we were to just knee-jerk and we were moving too quickly in the exam environment, you would say VDC, and then you would move on. Yeah, VDCs sound pretty good here, but if you think about the conservation of VLAN IDs and IP subnet conservation, it's private VLANs out of this list, isn't it? Yeah. We're not assigning a separate VLAN ID and therefore subnet to each device. That would be wasting VLAN IDs and subnets. Instead, we can say, all right, we'll take one VLAN ID and make it a sub VLAN ID in the private infrastructure, and we can put a subnet in that particular entity and draw from that same subnet address space in another sub ID. So we are able to really conserve on VLAN ID usage, subnet usage, IP subnet usage, and this is what, of course, private VLANs are all about. So be very careful when you're in the exam environment to make sure you look over all of the possible quiz choices before making your selection. In this nugget, we examined key commands that you should know for the verification and troubleshooting of VLANs and private VLANs. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.